Good afternoon, learners. My name is Mr. Ocheng Anthony, and today I'm going to take you through Integrated Science Grade 7. We are going to handle the fourth strand, that is force and energy, and the specific substrand that we are going to discuss today is electricity. Welcome. In our introduction, we defined the term integrated science as a broad learning area that normally involves the study of various branches of science together. Those branches of science that we study together in integrated science normally includes number 1, physics, number 2, chemistry, and number 3, biology. Physics is defined as a branch of science that deals with the study of matter and its relation to energy. Learners, before we proceed, it is important for us to understand some of the terms that we are going to come across in today's lesson. Term number 1 is a term that you are calling matter, and matter is anything that has mass and occupies space. Term number 2 is the term mass, and mass is normally defined as the quantity of matter in a substance. Normally, when we are in the lab, we have two types of apparatus that we can use for measuring of mass. Apparatus number 1 is an apparatus that we are calling a beam balance, and the second apparatus that we can use for measuring mass is an apparatus that we are calling electronic balance. Again, learners, I want you to understand that wherever we are measuring the quantities, we normally have certain internationally recognized units that we normally use. Those internationally recognized units for measuring of quantity, we normally call them the SI units, and the SI unit for measuring of mass is a unit we are calling kilograms. Again, the fourth term that I want us to discuss today is the term force. Force is normally defined as a pull or a push, and normally the SI unit of force is given in newtons. Learners, I want you to understand that we normally have different types of forces. There is a type of force that we call gravitational force. There is another type we call magnetic force. There is another type we call centripetal force. Still, there is another one that we call electrostatic force. Type number 5 is a type that we call action and reaction force. Type number 6 is a type of force that we call force of friction. Type number 7, there is a type that we call upthrust force. Type number 8 is a type that we call tension force. Type number 9 is a type we call elastic force. Type number 10 is a type we call cohesive and adhesive force. And finally, type number 11 is a type of force that we call surface tension force. The fourth type, the fourth term that I want us to discuss today, learners, is the term energy. And energy is normally defined as the capacity to work. Normally, the SI unit of energy is given in joules. This energy that we are talking about, learners, we normally get it from somewhere. Those places from where we get energy, we normally call them the energy sources. And the energy sources have been grouped into two categories. There is a category we call renewable energy sources, and there is a second category that we call non-renewable energy sources. I will begin with the category of energy source that we are calling renewable energy sources. And renewable energy sources, these are energy sources that do not normally get depleted whenever we are using them. In other words, we can say that renewable energy sources are the energy sources that we can easily recycle. Examples of renewable energy sources normally includes number 1, solar, number 2, wind, number 3, geothermal, and number 4, waterfalls. On the other hand, there is another category of energy source that we are calling non-renewable energy sources. And non-renewable energy sources, these are energy sources that normally get depleted or used up whenever we are using them. In other words, we can also define it as an energy source that cannot be easily recycled after we have used it. Examples of non-renewable energy sources normally include the following. Number 1, petroleum. Number 2, charcoal. Number 3, natural gas. Number 4, firewood. Number 5, coal. Number 6, biogas. And finally, number 8, nuclear energy. Grade 7 learners, I want you to note that normally energy has been grouped into different types. Those types of energy, we normally call them the forms of energy. And an example of the first type of energy is the type of energy that we are calling light energy. Light energy is normally generated from either the sun, the candles, or we can also get it from lamps. A second type of energy is the energy that we are calling heat or thermal energy. And normally, this is the energy that normally keeps our bodies warm. The third type of energy is the energy that we are calling electrical energy. And electrical energy is the energy that is normally caused by either movement or presence of electrical charges that we also call electrons. If the energy is caused by the movement of the electrons, that type of electrical energy we normally call it current electrical energy or current electricity. But if that energy is caused by electric charges that are stationary, or in other words, those that are not in motion, then that particular type of electrical energy, we normally call it static electrical energy or static electricity. The fourth example of a type of energy is a type of energy that we are calling sound energy. And normally, sound energy is the energy that is normally produced by vibrating objects. Another type of energy is chemical energy. And chemical energy is the energy that is normally stored in foods, in fuels, and also in battery. Finally, the last type of energy is the energy that we are calling mechanical energy. And mechanical energy is the energy possessed by an object because of its movement or position. If the energy is being possessed by an object because of the movement, then that particular type of energy, we call it kinetic energy. But if the energy is possessed by a body as a result of its position and not movement, then that particular type of mechanical energy, we normally call it potential energy. Learners, I want to give you a few examples of energy that we normally come across on our day-to-day basis. Example number 1 is when we are using a torch. Normally, a torch has dry cells. Those dry cells normally have chemical energy. And when we are using that torch to produce light, the chemical energy that is in the batteries is normally converted to light energy that we normally use for seeing when we are in the dark. Another example is when we are using a radio. If the radio is using electricity, the type of energy that will be there will be the electrical energy, and that electrical energy will be used to produce sound energy that will make us hear the music that is being played from that radio. The third example of energy is the energy from the sun. Of course, the sun produces an energy that we call light and heat, and the heat energy will keep us warm whenever we are basking. Now, learners, I want us to handle this type of energy that we are calling electrical energy. Remember, in integrated science, we've said that we normally study various branches of science together, and the branches are 3. The one that we are handling today is a branch that we are calling physics. And in physics, across the grades, we shall just be handling force and energy. And we have already defined what energy is and what force is. So the first type of energy that we are going to handle at grade 7 level is this type of energy that we are calling electrical energy. And electrical energy is normally defined as the energy that is caused by movement or presence of electric charges. Normally, electrical energy has been grouped into 2 categories. There is a category that we call static electrical energy, and there is a second category that we are calling current electrical energy. We are going to begin with category number 1, that is static electrical energy. And static electrical energy is the electricity that normally forms on the surface of an object, and normally it remains at rest until it has been discharged. Normally, this type of electricity is caused by an imbalance of electrical charges that we also call electrons that normally build up on the surface of an object. I want us to look at an example, or rather examples of static electricity in real life. Example number one is when a balloon is sticking to a wall after it has been rubbed on air. That balloon is sticking on the wall because we have some charges that have been built up on it, and those charges that have been built up on that particular balloon that are causing it to stick on the wall is the charge that we are calling electric charge. Example number two is when a person gets a small shock when he or she is touching a metal doorknob. And example number three is lightning that normally occurs during thunderstorm. Grade 7 learners, I want you to know that normally bodies that have static electricity or static electrical charges, those particular bodies normally get those charges by a process that we are calling charging. Now, I want us to discuss the various ways in which a body may get charged so that it can acquire those particular charges that we are calling static charges. Way number one of charging a body is through rubbing or friction, and this one will occur when you are rubbing a balloon on air. Way number two is by contact or by conduction, and this one normally occurs when when a body that is not charged is touching another body that has charges. Then way number three of getting charges on a body is by induction, and this one will occur when a body that has been charged is placed next to another body that has no charges. Learners, I want you to understand that normally this type of electricity that you are calling static electricity has a number of uses in day-to-day life. We are going to discuss some of the applications of static electricity, and application number one is that static electricity is normally used in photocopying and printing. During printing and photocopying process, the static charges normally attract the toner particles to the paper, and as a result, they will enable the formation of text and images on that particular paper. Application number two is that static charges are normally used in painting, and during painting, the charged paint particles are normally attracted to the object being painted, thus giving an even coat on that particular object that will be painted. Again, another application of static electricity is that it is normally used in pollution control, and during pollution control, it will be applied to remove dust and smoke particles from factory exhaust gases, and as a result of this, the amount of pollution that could have occurred will end up getting reduced. Again, learners, I want you to know that static electricity is also used in spray painting, whereby the charged paint droplets will improve the efficiency and coverage of that particular thing that we are painting. Then application number four is that it is normally used in filters, and in filters, the charged particles will help to trap dust, pollen, and smoke particles, thus purifying the system that is being filtered. Then the last application is that static electricity will be useful in removal of dust in some systems, particularly in industries that normally produce a lot of dust, like the cement processing industries and the rest. Again, learners, as we are using static electricity, I want you to know that it is important that we take precautions. Some of the precautionary measures that we must put in place when we are using static electricity normally includes number one, you must use insulated doorknobs. Number 2, you must ensure that you use anti-static clothing. Number 3, you must use anti-static wrist straps. And finally, number 4, you must use non-metallic handled drills in your day-to-day operations. With that, we are done with the first type of electrical energy that we are calling static electrical energy. And now I want us now to discuss the second type of electrical energy that we are calling current electrical energy. And current electrical energy is normally defined as the energy that results as a result of the movement of electric charges, and those electric charges normally move through a conductor that is normally a wire. Current electrical energy is normally divided into two types. There is a type that we are calling direct current, and there is another type that we are calling alternating current. Direct current is electric charge that is flowing in one direction. A good example is when the battery that is powering a torch is being used, and the current that are within it are moving from one point to another, particularly in one direction. Then for alternating current, in alternating current, normally the charges keep on changing the direction of the movement periodically. And a good example is when the power is being generated from power stations and being supplied to our homes and also to the industries where it is normally used for various purposes. Now, I want us to understand the sources of electricity. We have already known that we have two categories of electricity. We have static and we have current electricity. Normally, the sources of electricity that we are going to mention here are the sources of the current electricity, and those sources normally include: number 1, geothermal power plant; number 2, hydroelectric power plant; number 3, nuclear power plant; number 4, solar panels; number 5, windmills; number 6, dry cells or battery; number 7, we have fossil fuel; number 8, we have biomass; number 9, we have natural gas; number 10, we have fuel station, where we normally have some fuel that are normally sold there, like petrol and diesel; and finally, number 11, we have a source that we are calling tidal wave. Learners, as we handle electricity, I want you to know that there is something that we normally call electric circuit, and electric circuit is normally defined as the route through which the electric currents normally flow. That particular route is normally composed of a number of components. Some of the components that make up an electric circuit includes: number 1, we have dry cells; number 2, we have the connecting wires; number 3, we have a bulb holder; number 4, we have a switch; and finally, number 5, we have a bulb. Again, I want you to note those items that we have mentioned there. They are the main components of an electric circuit, but sometimes you can have other accessory components. The two accessory components that are normally sometimes located or found within an electrical circuit are the apparatus that we call: number 1, voltmeter, and number 2, ammeter. The ammeter is the apparatus that is normally used for measuring electric current that is flowing through an electric circuit, and on the other hand, a voltmeter is an apparatus that is normally used to measure the voltage that is flowing through an electric circuit. Learners, I want us now to observe these components of an electric circuit so that we may be able to know what we are talking about. In this diagram, we have a number of the components of an electrical circuit. The first component here is the component that you are calling a switch. Then a switch is followed by a bulb in that diagram. Then we have a bulb holder. And finally, number 4, we have the electrical wire. Apart from those, we still have another group of the components of an electric circuit. There is one here that you are calling the voltmeter. The voltmeter, you will identify it with the presence of capital letter V at the center of it. Then the second one is ammeter. An ammeter, you will identify it with the presence of capital letter A within it. And number 3, we have a switch. Again, learners, I want you to note that normally those components of an electric circuit, in some books, you might find them having been represented using symbols. Those symbols, or some of the symbols that you may get in your books, include the following. Symbol number 1 is a symbol of a capital letter A that has been encircled. Whenever you come across such a symbol, you must know that that symbol stands for ammeter. Again, the second symbol that you can come across is a symbol of capital letter V with a circle enclosing it. When you come across that symbol represents a voltmeter. Symbol number 3 is a symbol of a circle with an X inside it. That symbol normally stands for a bulb. Then the next pair of symbols is a symbol for switch. The first one is when the switch is open, and the second one is when the switch is closed. And finally, the last symbol is a symbol of a dry cell. Learners, make sure you remember these symbols because they are very important. Many a times you will find these symbols in an exam, and you'll be required to tell what it means. Now, I want us to see how an electric circuit can be connected. In this connection of ours, we have the components having been arranged in order. We have the dry cells here. Dry cells are followed by a switch. Then we have ammeter. We have the voltmeter, and finally we have our bulb holder with a bulb on it. That illustration, we can combine all of them together. So from the far left, we have the component of an electric circuit. You can see them. We have already discussed them, so I will not repeat that. Then at the center, we have an illustration showing how we can connect those components of an electric circuit to make a complete circuit that has a bulb that is lighting. Then finally, on the far end or the far right, we have the symbols of those components of an electric circuit that we have already discussed. Again, learners, I want you to note that whenever we are connecting an electric circuit, we normally have two methods in which a circuit can be connected. There is a method that we are calling series connection method, and there is another method of connecting a circuit that we are calling parallel connection method. In series connection, normally all the components are normally arranged end to end, forming a single path through which the electric current normally flow. On the other hand, in parallel connection, the components of an electric circuit are normally connected in two different points, making the electric current to flow in multiple ways or in multiple flows. I want us to illustrate what I mean by series and parallel connection. So in this first diagram that I have labeled A, you can see we are having the components of an electric circuit. We have the dry cells, we have the ammeter, the switch, we have the bulbs. Now I want you to pay close attention on these two components, the bulbs and the dry cells. As you can see, the two dry cells that we are having, all of them, they have been arranged end to end in one line. And at the same time, the bulbs that we are having in this circuit, bulb 1 and bulb 2, all of them have been arranged in a very close connection in one line. So whenever we are having the components, particularly the bulbs and the dry cells, having been arranged in a single line, that type of connection is what we normally call series connection. Now, I want you to pay attention again in our second diagram that we are having here. And I want to draw your attention to the bulbs. We have bulb 1 and we have bulb 2. These two bulbs, they have been arranged in such a manner that one bulb is below the other one, or in other words, the two bulbs have been arranged in such a way that all of them are parallel to each other. So whenever we are having a connection whereby the components of an electric circuit are parallel, have been arranged parallel to each other. That type of connection is what we normally call a parallel connection. Now, learners, I want you to know the following. These two types of connections are different in some ways. One of them is normally advantageous, while the other one is normally disadvantageous. The type of connection that is normally advantageous over the other one is a parallel connection, and some of the advantages of parallel connection includes the following. Number one, whenever you are having your connection in parallel, normally the appliances will always operate independently. This means that if one of the components fails to operate, like for example, one bulb gets burnt out, the remaining components will continue working. Like if one bulb is burnt out, the other bulbs will continue lighting. Advantage number two is that it is possible to have individual control over the appliances, such that you can easily switch off or on one of those components, particularly the bulb, independently without affecting others. So if you have your connections in parallel, you can easily switch on one bulb and leave the others lighting, or you can switch off one, you can switch on one and leave others without having been switched on. Advantage number three is that in parallel connection, we normally have brighter bulbs. Brighter bulbs because the current that is flowing within that circuit is normally not shared amongst the bulbs that are there. So the bulbs that you will be having in that particular house or in that particular room will be producing a lot of light as compared to another group of bulbs that will have been connected in a different type of connection that we are calling series connection. Apart from brighter bulbs, another advantage of connection of circuits in parallel is that addition of an appliance normally does not significantly affect others. So if your appliances have been arranged or connected in a parallel manner, whenever you want to introduce a new component within that particular circuit, the introduction of the new component will not affect the introduction of those components that were initially there. Then finally, advantage number 5 is that the bulbs will always have the same voltage because there is no sharing of voltage or current. Now learners, there is something else that I want us to discuss as far as electricity is concerned, and this is something that we are calling electrical conductors. And electrical conductor or conductors are normally the materials that will allow electric current to flow through them. So if a material is allowing electric current to pass or flow through it, we normally call it a conductor. On the other hand, those materials that do not allow electric current to flow through them, we normally call them the non-conductors or insulators. I want us to discuss the examples of electrical conductors that we have. A good example is a material that we are calling copper. Because copper is a good conductor of electricity, it is normally used in making wires and cables. Another example that is a good conductor of electricity is a metal that we are calling gold. And because of that reason, gold is normally used in electronics to prevent corrosion. Material number 3 that is a good conductor of electricity is a material that we are calling silver. Another good conductor of electricity is salty water. And finally, number 5, we have graphite that is normally used to make pencils. Now, I want us to look at the examples of materials that we call non-conductors. Examples of non-conductors, we have number 1, rubber, number 2, plastic, number 3, pure water, number 4, wood, number 5, glass, number 6, diamond, and finally, number 7, wool. Kindly don't mind my numbering. It is a bit messy, but just understand that those are the examples of the non-conductors that we have. Then I want us now to proceed ahead and look at something else. And now we are going to talk about something else that we call electrical appliance. Normally, An electrical appliance is normally defined as any device that is normally used to perform a personal function that is not industrial function, and that particular device normally uses electrical energy. Examples of devices that we call electrical appliances in our homes or in our day-to-day life normally includes an appliance like a blender, number 2 heater, number 3 laptop, number 4 washing machine, number 5 toaster, number 6 electric microphone, number 6 electric torch, number 7 we have another appliance that we are calling electric iron box, we have microwave, we have electric cooker, we have air conditioner, we have blow dryer, we have ceiling fan, we have electric oven, we have television, we have clothes dryer, and finally we have coffee maker. Now, whenever you are using electricity, learners, or whenever you are using these materials that we are calling electrical appliances, remember they are using electricity. So you are required to put some precautions in place. Precaution number 1 that you must always remember is that you should never insert metallic objects into electrical sockets. Number 2, you must always ensure that you switch off the electrical socket whenever you are not using them. Precaution number 3, you must always switch off electric socket before you plug in any electrical appliance. Precaution number 4, you should never overload a power socket. Then precaution number 5, you should never touch electrical socket, particularly when the electrical socket is naked. Then number 6, you must ensure that you do not wet electrical sockets or appliances. Number 7, you must always disconnect electrical appliance while you are cleaning it. And finally, number 8, you should not touch electrical poles or high voltage wires with your hands or with a metal. Learners, I want us now to look at the uses of electricity in day-to-day life. We've said that in this particular lesson, we are just handling the type of energy that we are calling electricity, and we cannot call it a lesson unless we know the uses of electricity in our day-to-day life. So electricity is very important. It will carry out the following functions or roles. Number 1, it is normally used for entertainment, like for example, when you are watching television or whenever you are listening to music on radios or in MP3 players. Application number 2 of electricity is that it is normally used in healthcare to provide powerful lights that are normally used for surgical operations. Number 3, it is normally used in engineering for welding the windows and also the gates. Function number 4 is that electricity is normally used to provide light in street lights. Function number 5 is that it is normally used to operate lawn mowers. And finally, the last use of electricity is that it is normally used in operating household appliances like laptop, television, and radio. With that, learners, we have come to the end of our lesson. Today, we have discussed that science or integrated science is a broad learning area that normally involves the study of various branches of science together. Those branches of science that we are studying integrated science, one of them is physics, and we have defined physics as a branch of science that normally deals with the study of matter and how it is related to energy. Again, energy, we have said, is the capacity to work, and we have said that energy is normally measured using an SI unit that we are calling joules. We've said that energy have been grouped into different types. There is a type of energy that we call light energy, we have sound energy, we have electrical energy, we have mechanical energy, we have sound energy, and other different types of energy. In this particular lesson that we've just concluded, we've said that electrical energy has been grouped into 2 categories. There is a category that we are calling static electrical energy, and there is another category that we are calling current electrical energy. Again, In current electrical energy, we've said that the path that is normally followed by electric current, we normally call it an electric circuit. An electric circuit, we've said that normally has a number of components. Some of those components normally include a bulb, an ammeter, a voltmeter, electrical wires, and also a switch. Again, we have learned today in our today's lesson that whenever we are connecting an electrical circuit, we can have two types of connection. Connection number one, we can connect our circuit in parallel, and at the same time we can connect it in series. Out of those two types of connection, we have seen that the most advantageous type of connection is the parallel connection, because number one, it normally allows the bulbs to produce brighter light. Number two, whenever one of the components of the circuit breaks down, the other components can continue working. And at the same time, we have seen that you can easily infuse a new component within the circuit without interfering with those other components that were there initially. So learners, today, that is the lesson that I wanted us to learn. It is my hope and prayer that you have caught something today that will help you not only in your exams but also in your day-to-day life. So just allow me appreciate you for your time. Thank you so much for attending to today's lesson. As you proceed to your other activities, I wish you all the best and may you have a successful day ahead of you. Thank you.